Hello everyone, welcome back to the Distributed Generation and Smart Grid lecture series. In this video, we are going to discuss about a typical microgrid configuration and what are the component and in that typical microgrid configuration. So it is a typical microgrid configuration is shown in figure. You can see that configuration. It consists of electrical or heat loads and micro sources connected through a low voltage distribution network. The loads and the sources are placed close together, as you can see in the schematics, to minimize, actually this will minimize the heat loss during the heat transmission. And you can see there are a lot of mainly there is a left hand side, from the beginning left hand side the dotted line are separate the main grid and microgrid. The main grid side you can see the transformer and circuit breaker, and the microgrid side you can see a low voltage bus and three feeders, feeder A, feeder B and feeder C, and in each feeder there are micro sources connected to this, that is the distributed energy resources, and loads are connected to this load. You can see everything is connected through circuit breaker, and you can see that microgrid connected to the main grid through a circuit breaker, that is CB4. So whenever a circuit breaker CB4 is open, means the entire microgrid is disconnected from the main grid. And you can see a lot of MC, that is the micro source controllers. And distributed energy resources, different types of energy resources that is connected to the feeder A and feeder C. In this case, feeder A and feeder C consist of energy resources. These are known as micro sources, and which is having a plug and play feature. You can connect or disconnect it, and they are provided with the PEIs, that is the power electronics interfaces. They are connected through power electronic interfaces to implement the control, metering, and the protection functions during its standalone or grid connected modes of operation. And these kind of control or power electronic converters are ensures the seamless transition of microgrid from one mode to another. And in this particular schematic diagram, you can see that it consists of three radial feeders A, B and C to supply electrical and heat load. And it also has two CHP. CHP means combined heat and power sources. It consists of two CHP and two non-CHP micro sources, and storage devices are associated with this. And the micro sources and storage devices are connected to feeder A and C through micro source controllers. Feeder B, there is no micro source, you can see that. And feeder A and feeder C connected with micro sources and the storage devices like battery through micro source controllers. That is MC. MC is the micro source controllers. And some loads on feeder A and C are assumed to be the priority load. Okay, and some loads on the feeder A and C are assumed to be priority loads. That is, the priority loads are the loads that requiring the uninterruptible power supply, and while other loads are non-priority loads. So feeder B, however, contains only non-priority electrical loads. That means even if a contingency occurs, any fault occurs in the main grid, you can ensure the power to the priority loads by keeping the connection to the particular feeder, and feeder B, as there is no priority loads, you can disconnect it. And you can see that the microgrid is coupled with the main grid, that is a medium voltage utility grid, and this is denoted as a main grid, through PCC, that is point of common coupling, and through the circuit breaker CB4. You can see that circuit breaker CB4 in the figure, and the CB4 is operated to connect and disconnect the entire microgrid from the main grid as per the selected mode of operation, whether it is a standalone or grid connected. And feeders A, B and C, however connected to the microgrid, even if we are disconnecting the entire microgrid from the main grid. And you can see that the feeder A is connected to the microgrid through circuit breaker CB1, feeder B is connected through CB2, and feeder C is connected through CB3. So micro sources on feeders A and C are placed quite apart from the microgrid bus to ensure the reduction in the line loss, good voltage profile and optimal use of waste heat. And you can see feeder A, you can as I told that it connected with the priority loads. If there is any fault occurs, you can keep disconnect the entire microgrid from the main grid and keep feeder A and C is continued to be in the operation, and feeder B can be disconnected through the circuit breaker CB2. And so the microgrid is actually operated in two modes, grid connected and standalone. So in a grid connected mode means the microgrid remains connected to the main grid either totally or partially, and it imports or export power from or to the main grid. In case of any disturbance in the main grid, the microgrid switches over to the standalone mode while still feeding the power to the priority loads. So this can be achieved by using this operation of circuit breaker, like disconnecting the entire microgrid by opening CB4, or we can disconnect in the feeders A and C by opening CB1 and CB3. Or another option is the microgrid will operate as an autonomous system with all microsources feeding all the load in the feeders A, B and C, whereas that is one of the option. Then another option, you can feeder A and feeder C will supply the priority loads while feeder B will be left open. Like that also you can operate as per your requirement. And mainly you can see this terminology like MCs, that is a micro source controller, and the operation and management of microgrid in different modes is controlled and coordinated through local MCs, micro source controllers, and the central controller. You can see central controller as CC. CC is the central controller, and whose main functions are actually, in case of a micro source controller, the main function of micro source controller is to independently control the power flow and load and voltage profile of the micro source in response to any disturbance and load changes. And so a micro source controller is a dedicated micro source controller is connected with all the micro sources. Central controller actually execute the overall control of the microgrid operation and protection through MCs. So its main objectives are to maintain the specified voltage and frequency at the load end through power frequency and voltage control, and it also ensures the energy optimization of the microgrid. So CC is actually dealing with the overall control. So it can also perform the protection coordination also. The protection coordination of the entire devices connected to the microgrid. So the central controller mainly will consist of two modules. These are some of the another pictorial representation of typical configurations that you can see from is selected from the internet, and you can see that these are the points we already discussed. microgrid configurations, and a central controller execute the overall control of a microgrid operation and protection. So it consists of mainly two modules, that is the energy management module EMM and protection coordination module. So energy management module provide set points for active and reactive power output, voltage and frequency to each micro source controllers. So energy management module can different kind of purposes. It will energy management module must control the following things, that is micro sources supply heat and electrical loads to the customer satisfaction. It ensures the microgrid operates satisfactorily as per the operational priori contract with the main grid, and it ensures microgrid should satisfy the obligatory binding in minimizing the system losses and emissions of greenhouse gases and particulates, and it ensures the micro sources operate at their highest possible efficiencies. So these are the some of the functions of energy management module. Similarly, protection coordination module, these are part of central controller, and this PCM will respond to the microgrid and main grid fault and loss of grid condition scenarios in a way so as to ensure the correct protection and coordination of the entire microgrid. And it also adapts the changes in fault current levels during the changeover from one mode to another, grid connected mode to the standalone mode. So the protection coordination module is actually mainly respond to the microgrid and main grid fault and the condition loss of grid scenarios. And these the heart of all these things is the communication between all these devices. In order to achieve all these functions by this protection central controller or micro source controllers, should be a proper communication between these kind of modules, PCM and the micro source controllers. So that is what makes the entire microgrid as a smart grid, like that. There should be a proper communication between them. And that is the functions of protection coordination module. Then there are some typical functions for central controllers in the grid connected mode. These are listed here. It works as a monitoring system to diagnostics by collecting the information from the micro sources and load, and performing state estimation and security assessment evaluation, economic generation scheduling, active and reactive power control of micro sources, demand side management, etc. by using this available collected information. And it also ensures the synchronized operation with the main grid by maintaining the power exchange at the priori contact points. And these are the main functions of central controllers at grid connected mode. And the functions when it is in the standalone modes are, it performs as active and reactive power control of perform the active and reactive power control of micro sources in order to maintain the stable voltage and frequency at the load ends. And it also adopting the load interruption or load shedding strategies using demand side management. And central controller will decide the such kind of strategies as a part of demand side management with the help of storage device in order to maintain the power balance and the bus voltages. And it also initiate the local black start to ensure the improved reliability and continuity of the services. Then switching over the microgrid to grid connected mode after main grid supply is restored without hampering the stability of either grids, either microgrid or main grid. So these are the functions of CC in standalone mode. So in this section we discussed the typical microgrid configuration, various components, various controllers, its functions, etc.